Hello. This is a continuation of our course on basic radio communication systems, and we'll get very basic. Probably the most commonly used radio system is the single frequency simplex. And the diagram that you see here, it looks like this. The base station has a transmitter. Let's say it's on frequency T1, and the receiver also has the frequency T1 as well. And in the simplex station, the receiver is normally disabled, or muted as we say, when the transmitter is operated. Otherwise, you'd hear your own transmitter, and your voice would come booming out of the receiver loudspeaker. So you may find a symbol on some systems diagram, this little circle here on the line connecting the transmitter and receiver, and this indicates that the receiver is muted when the transmitter is on. And you'll note from this diagram that the single antenna is shared between the transmitter and the receiver. Normally it's connected to the receiver, but when the transmitter is operated, there is a relay or some type of automatic switch that will transfer the connection from the receiver to the transmitter. So the operation of the system is quite simple. The base station talks out on T1 and mobiles receive it on R1. When the mobile operator wants to talk back, he operates his T1 transmitter and the base station hears him on R1. And by the way, it's possible to have direct mobile-to-mobile communication with this system. If another mobile is within a few kilometers of the first, the mobile operator can hear each other. And many people refer to our products as two-way radio. Occasionally we find a specification where the customer asks for a three-way radio system. Well, we have it right here. The simplex system provides base-to-mobile, mobile-to-base, and mobile-to-mobile communication. That's three ways. The single frequency simplex system has the advantage of being simple and direct, and it requires only one frequency too, which is important in some cases. It does have one serious disadvantage where the frequency is crowded with many users. Suppose there's another user a few kilometers down the road from the first station. What may happen is this. A mobile in our first system is transmitting to his base station, and he has a weak signal perhaps, maybe 1 microvolt, but it's usable. Then a base station located a few kilometers down the road wants to transmit. The operator might not hear the mobile who's using the channel, and so this other base station turns on his transmitter to call one of his own mobiles. And when he does, he'll put a strong signal back into our first base station, perhaps 10 microvolts or more. It's usually a very strong signal since radio losses are rather low between elevated antennas of base stations. And the law of FM capture says that the strongest signal wins. So the 10 microvolt signal from the second base station here will completely suppress the 1 microvolt mobile system signal. The mobile transmission is going to be interrupted right in the middle of a word, and the base won't hear them until the interfering signal stops transmitting. In a large city with many, many base stations, many radio users sharing the same frequency, what usually happens is many base stations will interfere with the mobile transmission. And the poor mobile operator is going to have to try several times to get his message back to the base station. This got to be such a serious problem that another system was devised to solve this capture problem. And this is the two-frequency simplex system. In block diagram form here, it shows the base station with separate frequencies for the transmitter and receiver. Transmitter, you see, is on T1. The receiver is on R2. The equipment itself is the same model that might be used for a single frequency simplex station. The receiver is normally muted during transmit, and the single antenna is switched between the receiver and transmitter as before. All we do is simply specify a different frequency for the receiver. Many governments will assign frequencies in pairs, so this two-frequency simplex arrangement can be used. The two-frequency simplex system has solved the base-to-base capture problem. The base talks out to the mobile on T1. The mobile talks back on frequency 2 and is heard on R2. If another base station is on the same frequency pair, he can operate his T1 transmitter, and he will not disturb mobile reception on the other station's R2. I should point out that direct mobile-to-mobile communication is not possible because of the frequency arrangement in this system, but that's not always a requirement. One taxicab, for example, normally has no need to talk to another taxicab. If the customer really needs direct car-to-car communication, what can be done is to provide the mobiles with a second transmit frequency, T1. Normally the mobile would use T2 to talk back to the base station, but if the operator wants to talk to another mobile, he can switch to T1, and then any other mobile within range will hear him. Thus, the two-frequency simplex arrangement provides more communication, since it eliminates this base capture problem. A common arrangement is to have the base transmit near 451 megahertz, and the receiver will then operate near 456 megahertz. In the 800 megahertz band, the spacing between transmit and receiver frequency is usually 45 megahertz. In the USA, the VHF taxi band has frequencies assigned in pairs for the purpose of two-frequency simplex operation. Another type of system arrangement is full duplex, and we normally don't see full duplex arrangements for dispatching type systems. The full duplex systems looks very much like this two-frequency simplex system in block diagram form, but the difference is the receivers at both the base and the mobiles are not muted when the transmitter is on. They're left open and operating at all times. And if this is done, special arrangements have to be made to prevent the transmitter from interfering with the receiver. Separate antennas for the transmitter and receiver must be used, or more commonly, a duplexer filter like this is used to combine the transmitter and the receiver on the same antenna without interference. The base and mobile equipment must be a model that's designed for full duplex operation, and there are only a few that are. And such models will include some extra shielding to protect the receiver, and will also provide the proper audio and RF connections. Instead of using a push-to-talk switch, full duplex systems often leave the transmitter on continuously for the duration of the conversation. And since the receiver is operating, the operator will be able to hear while he's talking. And you can interrupt a person just as you do on a wireline telephone. As a matter of fact, that's the main use of a full duplex system, to provide telephone service by radio. Cellular telephone systems are full duplex, microwave systems are full duplex, and there are certain models of trunking mobiles designed for telephone interconnect that are full duplex. But all this has extra costs, so that's probably the reason that such systems are seldom found on dispatching type systems. Repeater systems are very useful in system design and can provide considerable flexibility. Such systems provide wide area coverage for comparatively low cost. There are two major types of repeaters, the RT and the RA. The RT is a Motorola designation, which is an abbreviation for repeater talkback. These repeaters are no longer used for just talkback, but the designation for the model has remained. In the USA, the correct name for it is mobile relay. In other countries, it might be called a talk-through repeater. And the operation is quite simple. In block diagram form, with the repeater here, you see it has a transmitter frequency T1, and the receiver frequency is R2. The repeat function is indicated by this line with an X between the transmitter and the receiver. The repeater is designed to transmit on T1 any signal that it receives on R2. When the squelch of the receiver R2 is opened by some incoming signal, transmitter T1 is automatically turned on. In order to receive, while the repeater transmitter is operating, separate antennas for transmitter and receiver are required, or a duplexer filter must be used to combine the transmitter and receiver on the same antenna. So the station repeats or rebroadcasts incoming signals from mobiles or stations operating on frequency number 2. A mobile talking through such a repeater will be heard by all mobiles within range of the station. And this range can be very much greater than is possible with direct car-to-car communication because of the antenna height of the repeater station. So it relays mobiles, which is logically why it's called a mobile relay in the USA. Most users want to have communication between a dispatcher at their headquarters and their mobile, not just car-to-car communication. So to accomplish this, a control station is provided. And this station looks like a mobile in its arrangement. Notice it has T2 and R1, just like a mobile. So this station is repeated over the repeater RT, just like any other mobile. It has no priority, by the way. over a mobile and using the repeater, but that's normally not a problem. There's nothing special about the control station. It's normally a low-powered desktop station on the proper frequencies to operate the repeater. Its receiver is muted whenever the transmitter is operated. Using the control station to operate the repeater allows remote control of the repeater without the use of wire lines or some separate radio link. So the system is simple, it's flexible, and it's comparatively inexpensive. I should point out that if the repeater is out of service due to a power failure or a lightning strike, all communication is lost, gone. The control station can't talk to anyone, nor can the mobiles. So to solve this problem, there's another arrangement called repeater talk around. And used with this arrangement, the mobile is provided with a second transmit frequency, this one on T1. And if he wants to talk to another car directly, he can switch to T1, and then some other car with R1 can hear him if they're within range. And similarly, the control station can be equipped with frequency T1, which will allow communication with any mobiles within range. So repeater talk around can be an advantage in system operation. Two cars can talk directly with each other without going through the repeater. In police operation, often the cars are across the street from one another and they don't need the repeater. So if they switch to the talk around frequency, it keeps traffic off the repeater. But yet the cars can still receive the repeater for any messages from the dispatcher. One caution should be mentioned in connection with repeater talk around. Be sure the frequency switching capability of the mobile transmitters is wide enough to operate on both T1 and T2. There are some models that have rather narrow limits on the two frequency switching range due to tuned circuits used in their design. Two frequency receivers, by the way, have frequency switching limits also. So check our price book or the specification sheet for the frequency switching range on the mobile model that you're considering. Mobile relay systems can provide wide area coverage if more than one mobile relay is used. However, it's important that only one station at a time be operated. If all repeaters are using the same frequency pair, T1, R2, it's quite likely that a mobile at some location will be able to operate two or maybe more of these repeaters simultaneously in many locations around the area. And this is undesirable since the control station is going to be hearing distortion, heterodynes, and noise when all these signals combine together. Also, a repeater receiving a weak and noisy signal from a mobile might capture the control station receiver, and a repeater picking up a strong, quiet signal from the mobile might not be heard at all at the control station. One way to make sure that only one repeater at a time is operated is to select just one repeater from a mobile. And this can be done in a couple of ways. One way is to have different radio frequencies for each repeater. And the mobile operator will then switch to the proper frequency, the operating frequency of the repeater closest to his location. And mobile operators quickly learn which repeaters to choose at various locations. However, the large number of radio frequencies required for this arrangement here may be impossible to obtain. So another selection method is more commonly used. This other method selects the various repeaters by means of audio tone, or sometimes digital signals. And a good way to select repeaters is by means of Motorola's private line. Some, but not all, mobile models are available with this multiple private line capability. Each repeater receiver is equipped with a different private line squelch tone, A in this case, C here, and B at this repeater perhaps. So the mobile operator will then select the private line tone corresponding to the repeater closest to his location. Digital private line can be used in the same way. For very large systems with many, many repeaters, the tone capability may not be enough. So there's another arrangement using DTMF signaling tones which might be used. DTMF, by the way, stands for dual tone multiple frequency. These are signaling tones that are used for dialing telephones, the touch tone system in the USA. So each repeater has its own unique code to turn it on. The mobile operator might dial code 123 to actuate a particular repeater. When this repeater decodes 1, 2, 3, it can be operated by any mobile or control station. This code is only sent at the beginning of a conversation, after which the repeater is set up to operate on the following transmissions. The operator is supposed to send a turn-off code after the conversation is finished, but, well, many people forget to do this. So a timer is provided in the repeater. If no signals are received within, something like 30 seconds, then the timer resets the decoder, and a turn-on code will be required again before the repeater will operate. So please note, by the way, that the control station has to be equipped with whatever frequency or tone selection system is used by the repeaters. So it's possible to cover very large areas by using many, many repeaters arranged around some control station. The question is sometimes asked, is it possible to increase coverage by having one repeater repeat another? Well, yes, it's possible, but only if extra frequencies are available. It's not advisable to do this with a single pair of frequencies. If you try, this is what happens. A control station talks into repeater number 1 up here, and it's retransmitted on T2 as usual. And when it's received at this repeater number 2, it's retransmitted on T1. But T1 can be received back over here at repeater number 1, and this will keep the repeater on and transmitting. Since it's still transmitting, it'll operate repeater number 2 and keep it on permanently. This is called a lockup problem, and it's definitely to be avoided. Never place 2 repeaters with reverse transmit and receive frequencies in the same system. Even when you think they'll never hear each other, they'll find a way, and lockup will occur. This has happened with repeaters separated by hundreds of kilometers. There is a modification to the repeater RT that you might encounter, and it's called a community repeater. This is a means where several users, perhaps different businesses, will share a single repeater. I should say time-share a repeater, since only one person at a time can use it. The repeater is equipped with several private line decoders, A, B, C, and D, and so forth, and it's arranged so that the repeater will transmit the same private line tone that it receives. It won't operate on a signal without private line or some private line frequency that's not in its decoders. One user may have a fleet of mobiles operating on private line code A, and some other user may have a fleet of mobiles operating on private line code B. If a mobile with code A talks over the system, then all the mobiles in the system with code A will hear him. Mobiles with code B or any other code will not hear the conversation. So this provides a means for several different users to share the repeater without having to listen to the radio traffic on the repeater. So this arrangement does not provide any secrecy, I should tell you, between all these users, because the private line feature on the mobiles can be disabled by the operator. And this is done so the operators can monitor the repeater before transmitting to see if it's in use by some other group. The community repeater is not listed as such in the price book, but it's built by specifying multiple private line options on a standard repeater. Community repeaters have been quite popular among users that just have a few mobiles. Several such users can share a repeater in a good location and share the rental and maintenance cost of the station. Repeaters are very useful for providing coverage of large areas at low cost, but I should tell you they do have disadvantages as well. There has to be a certain amount of frequency separation between the transmitter and the receiver, so a receiver performance is not degraded when the transmitter operates. Shielding must be employed so the transmitter does not interfere with the receiver. And a duplexer filter must be used if operation with a single antenna is required, and these do have minimum frequency separation requirements that have to be observed. An entirely different repeater arrangement is the base and repeater RA. The RA is an old Motorola term that originally stood for repeater automatic. Another name for it that it's used outside Motorola is control and repeater operation. Essentially, all this is a base station that's remotely controlled by means of a radio link. The radio link replaces telephone lines which might not be available to the remote site. There may be a good site on a hill or a mountaintop, or the hill will provide excellent radio coverage. And the RT repeater station that we mentioned previously could be used, but perhaps the frequencies are not available, or the government may not permit RT operation. With the repeater RA, a simplex base station can be used at the remote site, T1, R1, and I should say some type of base station will have an option to permit RA operation. This provides the receiver squelch gate for R1 so that it will automatically turn on T2 when a signal is received. The RA operation also provides connections so that the audio from R1 is connected to T2, which is in a completely separate cabinet. Any audio received on R1 from a mobile talking in, let's say, is automatically retransmitted on T2, and the control station some distance away is going to receive it on R2. The control station can initiate a transmission back to the mobile after the mobile operator is finished talking. The control station will talk over T3. This is picked up by R3 at the repeater, and this is retransmitted over transmitter T1 on the base, and the audio then goes out to the mobile. The station with the T1 and R1 is called the base RA, and the station with the T2, R3 is the repeater RA. And you might wonder why we're using two different frequencies for the transmit and receive on the repeater. Well, we tried it originally with one frequency, but it has an undesirable effect. With the single repeater frequency, let's say if we made this T2, R2 instead, each time a mobile would talk in, you'd have to mute the R2 receiver whenever this T2 transmitter was on. If the control station tried to use the repeater while a signal was coming in, he couldn't. The muted receiver wouldn't allow access to the repeater. Well, normally he would have no need to operate the repeater when one of the mobiles was talking, but sometimes continuous interfering signal would be received at the base RA, and then they would operate the repeater for long periods, and when they did, the control operator couldn't use his own repeater. So to solve the problem, two frequencies are now used on the RA link. Receiver R3 is left on and operating when the transmitter T2 is on. So now the control operator can interrupt whatever is coming in and send a message over the system. In order to have the repeater RA receiver operate when the transmitter is on, either separate antennas, as shown here, or a duplexer with a single antenna must be used. By the way, it's a good idea on any repeater base RA or repeater RA to use private line to make sure that other users will not operate the repeater. The frequencies used for the RA link are restricted to certain bands in the USA, so be sure to check the rules currently governing the control and repeater operation. Also, for good operation, the repeater RA transmit and receive frequencies should be spaced by a couple of megahertz. Multiple repeaters might be used to increase mobile coverage, but as with the repeater RT, only one at a time must be selected by the mobile or control station. If the repeater is a very long distance from the control station, the radio losses may be too high for dependable operation. In such cases, it's possible to use a relay station between the control station and the repeater. And the best way to do this is to have another set of frequencies at the relay station. And you can see from the diagram how this works. If the control station initiates a call on T3, it's received at the relay station on R3. This is retransmitted on T4, which is received at the repeater on R4. And this in turn operates transmitter T1, which relays the voice transmission to the mobiles. And when the mobile talks back, he's received on R1, retransmitted on T5, received at the relay on R5, and this in turn is retransmitted on T2, and eventually it gets all the way back to the control station on R2. There are a couple of things to consider when a multiple hop path like this is used. And the first is time delay. Each one of the transmitters in the system may require anywhere from 10 to 100 milliseconds to come up to full power. The amount of time depends on the transmitter design. The receiver squelch takes time to operate also, and this might be in the range of 50 to 100 milliseconds. By the way, private line squelch may require up to 300 milliseconds to operate. So in a multi-hop arrangement, these delays will add up. As an example, if we assume for illustration that the transmitter and receiver delays are all 100 milliseconds in this system here, then the total number of transmitters and receivers here will provide 600 milliseconds total delay. And this includes the control transmitter and mobile receiver as well. Well, 0.6 of a second delay before anything is heard may be tolerable to some users, but if there were more relay stations than shown here, then the delay could be well over 1 second before anything could be heard. And since people will often not wait to speak after they press the microphone switch, the first word or words may be lost. And this could be a serious problem if you were a policeman transmitting the command, "Don't shoot." The second consideration in multiple hop systems is the audio frequency response change. Each transmitter and receiver reduces the audio response by 3 dB at 300 and 3000 hertz in the audio spectrum. So with one hop, the response is going to be 6 dB down at these points. With 2 hops, the response is going to be 12 dB down. And, well, you can see what is going to happen with additional links. The attenuation of the high and low audio frequencies is going to add up. And with several links, the audio quality may be unacceptable unless some measures are taken to improve the response. Multiple hop systems most often use microwave, which is on continuously, and this eliminates the delay problem. Microwave also has wide frequency response, which does not degrade with many repeaters. When wide area mobile coverage is required, there's usually a base station at each repeater site here to talk to mobiles. And notice these base stations use 2-frequency simplex. And this is done so the base transmitter is not heard in the next receiver down the line. The mobile should select which base station he wants to use, just as with other multiple repeater systems. Another possible arrangement is to use an automatic selection scheme where a comparator at the control point selects which receiver has the best signal. And we'll discuss that arrangement in a later program. Where repeaters are arranged in a line like this, the system is called a backbone type system. This point-to-point link here serves as a backbone to connect all of these base stations together. And it's useful for coverage of pipelines and highways. There are some types of repeaters that are installed in a vehicle. And I'm not referring to base stations that are installed in a van, which is sometimes done for temporary systems. There's another type of vehicular repeater called the Motorola PAC-RT. There's another version of it called the VRS, Vehicular Repeater System. The purpose of this unit is to provide communication between a base station and a portable by using the mobile unit as a repeater. Well, portables normally have low transmitter power and have to use some inefficient antennas, and as a result they have limited range back to some base station. So the PAC-RT was designed for situations like, well, a police officer who normally has a mobile but must occasionally get out of the car and still maintain communication with his base station. The PAC-RT is an add-on repeater unit that might be adapted to several types of mobile units. It has a small enclosure. It's installed near the driver of the car, which contains the portable radio. In block diagram form, the system looks like this. The mobile can be simplex, T1R1, and the PAC-RT can be simplex as well, but on T2R2. The mobile and the PAC-RT are usually on different frequency bands, such as 150 and 450 megahertz, to avoid interference between the units. When the portable is removed from its enclosure in the car, this turns on the PAC-RT. And when the portable transmits on T2, this will be received at the car on R2, and the PAC-RT will automatically turn on the mobile transmitter T1. The PAC-RT is arranged to do this only if there are no signals present on the mobile receive frequency. If there is an existing signal being received on R1, the repeater will not operate the mobile transmitter. This avoids interference to others using the radio channel. The PAC-RT is intended for limited portable range applications. The PAC-RT transmitter has only 250 milliwatts of power. But since the operator is not likely to walk very far away from the car, this power is usually more than enough. There is a consideration when several PAC-RTs are used at the same location. and this might occur in a police system where several cars are sent to the same address. If all of these operating PAC-RTs operate on one portable transmission, several of them could be received simultaneously back at the base station. And the base station would hear all sorts of noise and distortion from the resulting combination of signals. It's really not practical to tone select these individual PAC-RTs as is done with fixed stations. So Motorola uses a clever scheme to ensure that only one repeater is operated at the location. It uses timing. Basically, it arranges the repeater so that one is faster than all the others in its operation. And the first one that operates prevents all the others at the same location from turning on their transmitters. There's a similar type repeater called the PAC-PL, which doesn't have this timing feature and should be considered only in systems where several mobile units are not likely to be together. Other versions called the PAC-TR and the PAC-TL are offered for trunked radio systems. So this concludes our program on basic radio communication systems.